Pituitary gland and its hormones. Pituitary gland is located behind the optic chiasm. The bone named sphenoid bone is where the pituitary gland is sitting on sella turcica. Foramen magnum is close by where spinal cord meets brain stem. Neuropathway exits and enter the brain. There are two lobes of pituitary gland, anterior or adrenal hypophysis and posterior or neurohypophysis. Here hypophysis means pituitary gland. Both of these lobes are controlled differently and secrete different hormones. Diencephalon has two parts, hypothalamus and thalamus. The downgrowth from the diencephalon is the beginning of neurohypophysis. Anterior lobe starts from the pharynx-Rathke's pouch. It goes and almost fuse with posterior pituitary and make adrenal hypophysis. These two hypophyses function differently due to their origin. Neurohypophysis is regulated by hypothalamus itself. Just above the optic chiasm, there is a first nuclei called supraoptic nuclei that contains osmoreceptors. The neurons found in this area are sensitive to sodium management in our body. They control osmolarity in our blood. When we get thirsty, that means we have more sodium and less water in our body. These receptors sense the sodium is abundant, and through the axon going towards the posterior pituitary, they have posterior pituitary secrete a hormone, ADH, means antidiuretic hormone. ADH will go to the kidneys and stimulate them to retain water. The second nuclei in hypothalamus is called paraventricular nuclei. Neuron from paraventricular nucleus goes to neurohypophysis. They control the hormone oxytocin, which is used in uterine contractions. Prolactin from anterior pituitary is responsible for milk production, which is stimulated by oxytocin. Anterior pituitary or adenohypophysis is controlled by portal system. Portal system consists of artery, capillaries and vein. When blood comes in through the artery in the arterial side of the capillaries, all the nutrients will be sucked in by the muscles, and when the blood goes to the venous side of the capillary bed, it will suck all the waste and gases from the muscles. In anterior pituitary, there is a vein which is connecting primary capillary plexus to secondary capillary plexus. Superior hypothesial artery brings blood in the anterior pituitary. Inferior hypothesial artery brings the blood to posterior pituitary. Trabecular artery connects inferior and superior hypothesial arteries. There are capillaries in posterior pituitary gland as well. So suppose from anterior pituitary, thyrotrope cells secrete TSH, thyroid stimulating hormone. In thyroid hormone, T3 and T4 are responsible for BMR, basal metabolic rate, means how many calories you consume while resting. Hypothalamus will release TRH, thyroid releasing hormone in the primary capillary plexus in the anterior pituitary. Portal vein will take this hormone, and through the secondary capillary plexus they will force thyrotropes to release TSH, and this TSH will get absorbed by secondary capillary plexus and will go to the circulation via hypothesial vein. There are two types of hormones, and with trophics and with tropes. Trophic control another tissue or gland directly, like ADH, antidiuretic hormone controls renal water retention. Or TSH production from anterior pituitary will affect on thyroid gland size and activity, and that will increase T3 and T4 production, and BMR will go up. Tropes are the cells of anterior pituitary to synthesize and secrete various hormones. Anterior pituitary hormones: growth hormones, TSH, thyroid stimulating hormone, ACTH, adenocorticotrophic hormone, and prolactin. And also gonadotropes like FSH, follicle stimulating hormones, and LH, luteinizing hormone in females. Somatotropes are responsible for synthesizing growth hormone. Growth hormone is the only hormone exerts its functionality directly on target cells. Protein synthesis will go up, lipid metabolism will go up, glucose metabolism will go down, liver, bones, and muscles will be affected. Muscles are amitotic, means they can divide, so they will grow through metabolism, especially protein synthesis. Translation and transcription will go up because of growth hormone. Average protein in size is almost 25,000 amino acids in size, and for every amino acid to produce, we have to burn 1 ATP. 1 gram of fat has 9 calories, and 1 gram of carb and protein has 4 calories. Growth hormones decreases glucose transportation in the cell, so we rely on fat as energy source than glucose. Growth hormone also decreases protein catabolism or breaking down the protein. Somatomedin, IGF, are the messages of growth hormone in the body. Somatomedin affect on the secretion of growth hormone itself as well. Growth hormone is secreted throughout the day but go on its peak in 2 hours of deep sleep. Starvation makes growth hormone secretion go high. If we are hungry, we don't have glucose, we have to start burning fat. In a disease called kwashiorkor, when no food and especially proteins available to eat, body will start eating itself. Plasma protein will be low, albumin will be low, and we will have hard time retaining water in the blood. Water will spill out in the abdomen, so we will have skinny arms and legs, but big belly. If we increase protein intake, the growth hormone level will go down. Hypoglycemia. If we have low blood sugar, this will affect the growth hormone to make blood sugar level go high. Exercise. We need bigger tissues and bones, so growth hormone level will be high. Excitement and trauma increases growth hormone too. Hypothalamus releases GHRH, growth hormone releasing hormone, that increases the activity of somatotropes, which increases growth hormone production. As somatomedin or IGF goes high, they will shut off the release of GHRH and growth hormone level will drop. If growth hormone level is not working properly, it will cause gigantism or dwarfism in children because of the growth plates. Acromegaly happens to adults. Acro means extremities. This person will have normal height, but all the extremities will be